So this is pre-calculus 2.2 day 2. This is a correction for this last example from the other video that has an error in it. So anyways, you have a open box and we're with locking tabs from a square piece of material. So you'll notice that the dimensions are 24 by 24. So you're starting with a square piece of material. And you're cutting equal sections from the corners and folding along the dashed lines. So you have two X's on this side and two X's on this side that you are cutting off a length of 24. And you're folding them up once, and then this is going to get tucked in over the edge and try to make it a little bit stronger. And so, but on the other side, we are just taking off X on this side and X on this side. And then that is just folding straight up. That's just folding straight up. And so what we want to understand is the base of this box. How long is this? Well, you've taken off 2X on this side and 2X on this side. So this is 24 minus 4 times whatever X is. While on this length, you've only cut off X here and X here because that's just folding straight up. And so this length right here is this length, and it is just 24 minus 2X. And for volume, they want you to write a function for volume that represents, or for V that represents the volume of the box. And volume is length times width times height. Well, we've got a length and we've got a width, but we have to figure out height. And the height is X. When you fold that side up, that height is X. For the double X, it's folding up, but then this X is going to tuck inside the box, so the height is just X. And so the volume is X times 24 minus 2X times 24 minus 4X. That's your volume. Then it says determine the domain. Well, this is kind of, it takes some puzzling out and thinking through, which I've already done. So, you have to think through things. You can only have a length of 24. So how big can I let X be before I've used up all 24? And so if I use X, so 1, 2, 3, 4, that it is all 4 of those add up to 24. So these two X's plus these two X's add up to 24. Well, that would mean that each of them are 6 units. But if I let X be 6 here and 6 here and 6 here and 6 here, you don't have any length for the base. So X can approach 6 theoretically, right? If I let them all be 5.9, then this length from here to here would be what, 0.4? If I let them all be 5.9? Not very practical, right? But theoretically, it can be that way. So we're restricted by the fact that if I let X be 6, that would actually not leave any length for this side. So I can approach 6, but it can't be 6. Theoretically. And it has to be positive, or you won't have any height to the box. So that is the domain. And then we need to sketch a graph of the function and estimate the value for which it is volume's a maximum. Well, we have the zeros, or we can find them. And, what makes this 0? Well, when x is 0, it will be 0. And then if I solve for what makes 24 minus 2x 0, that is 12. So 12 makes that 0. And similarly, if I solve for what makes 24 minus 4x 0, I get 6. So I'm going to put those in a number line. We have 0, we have 6, and we have 12. And so if we do the sign test, my intervals are negative infinity to 0, 0 to 6, 6 to 12, and 12 to infinity. And then I need a test number in each. So -1, +1, 7, 13. And one thing I saw in some people's papers that I graded in the last class is they didn't show me the factors. I need to know what you're plugging these into. And then what is your overall sign? And when I put -1 in for x, it's negative. A -1 into the next, it's positive. And a negative into the next, it's positive. And a negative times positive is negative. So it's negative in that interval. If I put in 1, it's positive here, and it's positive here, and it is positive here, and overall the sign is positive. If I put in 7, I have positive here. 24 minus 14 is still positive. 24 minus 28, however, is negative. So it's negative here. And if I plug in 13, I have positive, but the other two both become negative, and it ends up being positive. That's the kind of work that we wanted on yesterday's homework 33 through 47 to help support the graphing. And so anyway, so it's negative, positive, negative, positive. Furthermore, I can look at the leading term and end behavior. Now, we're not taking time to expand this, but if I want the term with the highest power, it's going to come from when I take x times the -2x times the -4x. That's what, when you get it all multiplied out, is going to give me my leading term. And that's 8x cubed. And so my leading term would be 8x cubed. And so since it's cubic and the leading coefficient is positive, my end behavior looks like this. And notice that going to negative infinity as x goes to negative infinity is supported by my sign chart. As x goes to positive infinity, y is going to positive infinity is supported by my sign chart. So if I sketch a graph, zero, 0, 6, 0, and 12, 0. With that sign graph, I have to be coming from negative infinity. Each of these are of multiplicity 1, they're odd, so it's going to pass through. It's going to be positive, it's going to come back through at 6, pass through again, and come through 12, and pass through again. How high it goes here, how low it goes here, we have to do more work for that. But for just a sketch,